Hello, welcome back to Math Magical. We're going to look at how to interpret circle graphs. Now, some of you may not think of circle graphs in your head right away, but if I say pie chart, you might think of what we're talking about. So circle graphs, pie charts, they're all the same thing. We just typically call them circle graphs now, but if you're used to the other terminology, they could also be called pie charts. So what is a circle graph? A circle graph just shows the percentage of each data set compared to the whole. So when you see a circle graph, it's showing you the portions of 100. Remember, when we see anything that's a percent, that percent literally means per 100. And if you think about it, 1 cent in US dollars is 1/100th of a dollar. So here we have a pie chart and we can see, or a circle graph, we can see that students were asked to choose their favorite color. 20% chose blue, 35% chose red, 15% chose yellow, and 30% chose green. And our question asks, how many students chose blue? So we're going to try to find 20% of 60. Now remember, 20% can be written as a decimal as 0.2 or as a fraction as 20 over 100. So earlier in the school year, you learned about converting percents to decimals and fractions. So when we're about to do some math with percents, we want to convert it either into a decimal or a fraction. Typically, we go to the decimals though. So we're going to do 0.2 representing our 20% times 60. And you know that 2 times 6 is 12. So then 0.2 times 60 would be just 2 times 6 is 12. 120, shift the decimal point over, you're back to 12. So 12 students liked blue. All right. So interpreting data on a circle graph with percentages. So now let's look at what if they say something like, how many more students preferred red to yellow? Well, there's a couple ways we can handle this. The first is to figure out how many students chose red and how many students chose yellow, and then just subtract. So if 35% chose red, we can write that as a decimal as 0.35 times 60. That gives us 21 students. Yellow is 0.15 times 60, which gives us 9 students. So then we're going to do red minus yellow, or 21 minus 9. And that tells us that 12 students preferred red to yellow. So 12 more students chose red than chose yellow. Another way we could have done this was just straight away subtracting our percentages. So 35% chose red, 15% chose yellow. That means 20% more chose red than yellow. 20% of 60, we already did this earlier, it's 12 students. Now, if you're wondering, I have a quick mental math trick here for figuring out percentages. We know that 20% is just 10% twice. So in my head, when I'm doing this, I think, well, what is 10% of 60? Because 10% of 60, you just shift the decimal one to the left. So 10% of 60 is 6, but I need 20%, so I need 10% twice. So 6 times 2 is 20. So just a quick tip, if you're ever trying to figure out like a percentage of something, you're in a store, something's on sale, and you want to know how to do it, the quickest way to do that is just to figure out what's 10% of that value. And if it's asking for something that ends in a 5, like in this example, well, half of 10% is 5%. So if 10% is 6, then 5% is 3. And so you can really easily kind of figure out those percentages if you just go to that, not quite base unit, but that 10% unit, and then build up or down from there. Okay, so what if on this circle graph, instead of giving us percentages, they give us fractions? So if we look at this, it says 80 students were asked to choose their favorite subject. Unsurprisingly, with a math teacher making this, half of them chose math, right? 2/10 chose science, 1/5 chose history, and 1/10 chose English. And the question asks us, how many students choose science? So if we look at this, it's 2/10 choose science. So we can think of this as 80 times 2 over 10. Well, I like to do 80 times 2 and get the 160 and then divide by 10, which gives us 16. You could also think of this as 80 times zero point 0.2, which also would give you 16. Either way, you're going to get to the same answer. Then what if it says something like how many more? So again, we have how many students choose math over history. So we have 1/5 that choose history. Well, we can't really do 1/5 minus 1/2 or 1/2 minus 1/5. So what we want to do here is get everything into a common denominator. So 1/5 we're going to think of as 2/10, and 1/2 we're going to think of as 5/10. These are equivalent fractions. So we can do 5/10 minus 2/10, which equals 3/10 more. And then we can do 80 times 3 divided by 10, or 80 times 3/10. So that gives us 240 divided by 10, or 24 students chose math over history. You also could have gone the other route where we figured out, well, half of the students is 40, 2/10 of the students is 8, right? 16. 1/10 is 8, 2/10 would be 16. 40 minus 16 is 24. So again, you could have done that either way. I prefer to just subtract the fractions or subtract the percentages up front and then just find that percentage one time. And just a quick rule review. When we're adding and subtracting fractions, we must have a common denominator. So 1/2 and 1/5 would share a common multiple of 10. So if we do 1/2 times 5 over 5, that's going to give us 1 times 5 on the top and 2 times 5 on the bottom, which is 5/10. And then the 1/5 will multiply that by 2 over 2, which is 1 times 2 on the top and 5 times 2 on the bottom, which gives us 2 over 10. So that's how earlier in the lesson we did those conversions to get those equivalent fractions. Remember, if you multiply any fraction by the same number over the same number, that's the same as multiplying by 1. So 5 divided by 5 is 1, 2 divided by 2 is 1. So you're changing the numbers within the fraction, but its value is staying the same. 1/2 is equal to 5/10. They're both equal to 1/2. 1/5 is equal to 2/10. They're just in a form that we can now work with. Also, when multiplying by 10 or dividing by 0.1, we shift our decimals right as the number is getting bigger. When dividing by 10 or multiplying by 0.1, we shift our decimals left as the numbers are getting smaller. And that's it for today. So discover the secrets, unlock the magic, and let math take you on an adventure, and keep every day math magical.